Think math.
Here is a curious fact. Square sin²θ, square cos²θ, and add them, and you always get one. Whether theta is 30 degrees or 120, any angle at all gives one. The angle keeps changing, so why does the sum never budge? From a point on the unit circle, drop a perpendicular to the x-axis. A right triangle appears, a base, a height, and a hypotenuse. Apply the Pythagorean theorem here, and base squared plus height squared equals hypotenuse squared. Now swap the three sides for coordinates. The base is the x-coordinate, which is cos²θ. The height is the y-coordinate, which is sin²θ. And the hypotenuse is the radius, so it is 1. Swap them straight in, and cosine squared plus sine squared equals 1. We proved nothing new here. We just rewrote Pythagoras in coordinates. So what happens when the angle turns? As the point slides round, the base and the height keep changing. One grows while the other shrinks. But the hypotenuse never changes at all. On the circle, the distance from the center is always 1. The right side is pinned at 1, so the sum on the left is pinned too. You might worry about obtuse angles, but there is no problem. In the second quadrant, cos²θ is negative. The base is the absolute value of cos²θ. Yet the moment you square it, that minus disappears. Minus 1/2 squared is 1/4. So plus or minus, the sum of squares is still 1. That is why this holds for every angle. To sum up, this is not a formula to memorize. It is the very fact that the point sits on a circle of radius 1. Translate the Pythagorean theorem into the language of coordinates, and you get this one line. That is why we call it an identity. Any angle you put in makes it true. A sip of math every day with Think Math.